This video explains how to convert a given matrix A into its reduced row echelon form. So 2 points we must remember to convert this matrix A into its reduced row echelon form. We can perform only row operations, and the first entry in a row must be a 1. So this is the matrix which is given to us A, and we need to first reduce it into its echelon form. So I perform R2 as R2 minus 4R1 and R3 as R3 minus 7R1. Therefore you can see that this matrix A is now converted into this form, and the contents 4 and 7 which were initially there in matrix A are now converted into 0. The reason why we are doing this is because for a for an echelon form matrix, you need all the elements below the main diagonal to be zeros. In the next step, I perform R3 as R3 minus 2R1, and you can see what changes have happened. The first row remains the same, the second row remains the same, and the third row becomes 3 zeros and minus 2. Now again, with the main diagonal, I need all ones, and everything below the main diagonal I need as zeros. Therefore in R3 I perform minus R3 by 2 to get rid of this minus 2, and in R2 I perform minus R2 by 3. When I do that, this minus 3 will become 1. So this is the matrix that you get. So you have 1 2 3 1 minus 1 0 1 2 minus 7 by 2 0 0 0 1. Now you are left with these factors. You must remember that the first row, the first non-zero entry must be a 1, and also rest are 0 in that column. So once I get the first non-zero entry as 1, in that column all other elements must be 0. Now here when I get a 1 here, I am not getting other entries as 0, right? So there should be a way by which I can convert this into a 0 as well. Again, the first non-zero entry is 1. However, these two elements are not 0. So this is one of the things which is required for a reduced row echelon form. So let's proceed from here. I write R1 as R1 minus 2R2. Therefore, now in the next step I have marked these values. These are supposed to be the first non-zero entries, which are 1, and I must see that in that column all the other entries must be 0. So I am good here in this column. Now with this operation I am also good here in this column, because I have the first non-zero entry as 1, and in that column the other things are 0. I don't have to worry about here because the first non-zero entry is not 0. However, I need to worry here in this third row. The first non-zero entry is 1. However, these two are not zeros. Therefore I must do something to make this column other elements also 0. So I perform R2 equal to R2 plus 7 by 2 R3, and once I do that, then I get this matrix. Now I have this third row 1. I am getting this factor as 0, but this factor again is not non-zero. Therefore I perform this equation here, and that now the matrix which I get looks like this. In the first row, the first non-zero entry is 1, and the column corresponding to this entry all other elements are 0, so I am good here. In the second row, the first non-zero entry is 1, all other entries in that column are 0, so I am good here as well. In the third row, the first non-zero entry is 1, and all other contents in that column are 0, therefore I am good here. Hence I can say that this matrix which I have obtained is a row reduced echelon form of the initial given matrix A. Now you must also remember one final point: the pivots in the column can be the only non-zero term there. So these, which are the pivots here? This is a pivot here, this is a pivot here, and this is a pivot here, and these are the only elements which can be non-zero in that column.